Now we're going to devote 2 lectures to the topic of image processing. This is the first of the 2 lectures. In image processing, we're given an image and we want to transform this image into a clearer image or an image that's easier to analyze. So let's talk about a clearer image. Let's say you take an image of a scene at nighttime and it happens to be grainy or noisy for lack of light. We want to be able to remove the noise from the image. Or let's say that you had a fast-moving object and you take a picture of it, the object gets smeared in the image. That's called motion blur. We want to be able to remove the smearing and create a crisp image of the object. Or in a different scenario, you may be taking an image of an object, but for some reason while you're capturing the image, the object happens to be out of focus. It is defocus blurred. We want to be able to remove the blur from the image so that the object is nice and crisp. So that's the business of creating an enhanced image or a clearer image. And then you also have the problem of recovering information from the image that is more salient to the problem that you're trying to solve in computer vision. For instance, you have the image of a scene and you may want to enhance the edges in the scene, or you may want to enhance the corners or other interesting points in the scene. This can also be done using image processing. So image processing tools lie under the hood in any computer vision system and are extremely important. So here are the topics we're going to cover in this first lecture on image processing. We're going to start with pixel processing, which is the simplest type of image processing you can apply. You simply go to each pixel in the image, you look at the brightness or the color value, and you transform it using some predetermined mapping. You're not really concerned about where the pixel lies in the image. It is really a transformation that is based on the color or brightness value at that pixel. Very simple processing. Next, we're going to talk about linear shift invariant systems. This is a very important class of systems in image processing. A lot of operations that are applied to images are linear and shift invariant. And turns out that any system that is linear and shift invariant can be implemented as a convolution. So we'll look at what a convolution is, an extremely important concept, and look at the properties of convolution. Then based on convolution and linear systems theory, we can develop a suite of linear image filters, very simple to apply as they can be applied using convolutions. We'll see what kind of modifications we can apply to an image using linear image filters. And then we'll argue that there are certain things you want to do to an image that simply cannot be done using convolution. And that takes us to the class of nonlinear image filters. You can view these as more algorithmic in nature. You have a pixel and its neighborhood. You want to look at the values in there and apply some sort of a simple algorithm to it to come up with the output value of that pixel. And next, we'll talk about the important problem of template matching. You're given a certain pattern, and you want to find this pattern everywhere it appears in an image. And it turns out you can solve this problem using correlation, which is related in some ways to the concept of convolution.